Hi guys, you're welcome back to Allogenous Ideas. In this video, we are going to be talking about sets, okay? So let's explore Python sets, which are an ordered collection of unique elements, okay? Unordered collection of unique elements. If you want to create a set, you can use the curly braces or you can use the set constructor, all right? So if I can want to create a set of maybe numbers, for example, then equal to, then I can decide to do this using the set constructor, which is set. Then I pass in a list of numbers 1 comma 2 comma 3 comma 4. I can also decide to do this using, so let me say nums equal to, I can use the curly braces 1 comma 2 comma 3 comma 4. Okay, these are the two ways you can create a Python set. And if I should come here to print numbers, I should come here to print numbers and I run it to see I'm having this one. Then if I should print nums, I will be having the same thing exactly. You can see both of them are valid Python sets. Okay, and like I said, sets are, they are unordered, so you cannot index them. Okay, they are unordered, so there's no particular index to them. Then let us talk about adding and removing elements in a set. You can add elements using the add method, and you can also remove elements using the remove method. If I want to add an element to nums, for example, all I have to do is just nums dot add maybe 7. If I should come here to nums dot add 7, then let me print nums. So run this. You see that initially this is what I was having for nums, but I've added 7. So that is why I'm having this list over here. All right. So if I want to remove an element, let me remove 3, for example. So nums dot remove 3, and that is it. Run this. You see, I don't have 3 anymore. So that is how you can add and remove an element from a set. Now let us talk about set operations. Okay, let's talk about set operations. So set operators allow you to perform various operations on sets to create new sets. So these are some of the common operators that we have. The first one we are going to be talking about is the union. Okay, is the union operator. So let's say we have set 1 equal to maybe one set 1 comma 2 comma 3 comma 4 comma 5. Then I have set 2 equal to a set, then I'll do something like 4 comma 5 comma 6 comma 7 comma 8. Then for me to find the union sets, all I have to do is just to use the pipe operator, the union operator basically. Set 1, then you come with the pipe. Set 2, and this will get the union of the two sets. Okay, so just print the union set. If I should run this, guess what, I'm going to be getting the union of the two of them. Don't forget that I said a set is an unordered collection of unique elements. You will see that I have 4 here, I have 4 here, I have 5 here, I have 5 here. It will automatically filter out all the duplicates. It will automatically filter them out. All the duplicates, it will take it out. Let me bring back these nums, for example. If I should come here to add extra 2's, okay, no, 2, 2, and 2. You can see how many 2's I have in this set. If I should try to print nums and I run the code, you see that it will filter out all the excesses. Okay, it will filter out all the duplicates, rather, all the duplicates. So that is how to find your union sets. So we can also find the intersection. Okay, the intersection of two sets contains elements that are common to both sides. Okay, it contains elements that are common to both sides. How can we find the intersection? So let me say the intersection. You use this ampersand operator. This ampersand operator, use it to find the intersection. So intersection. So our intersection is going to be 4 and 5 because I have 4 and 5 here, and I also have 4 and 5 here. So run the code and you see I have 4 and 5. Let me clear my terminal. and I run this, you see I'm having 4 and 5. That is the intersection. So we also have the difference. Okay, the difference of two sets contains elements that are in the first set but are not in the second set. How can we do that? So just this, the normal minus operator, difference. All right, so run the code. You see I'm having 1, 2, 3, 4 and 5. 4 and 5 exist in the second set, so obviously our result is going to be 1, 2 and 3. We also have the symmetric difference of two sets which contains elements that are in either of the sets but not in both. Okay, it is in either of the sets but not in both. So the symmetric difference, so we are going to be using the caret. If you know your caret, this is should be on the Windows keyboard, it should be shift 6. Yes, the caret. If I should run this, so it is not going to be giving me 4 and 5 now. Okay, the symmetric difference are elements that are, like I explained it, so elements that are in either of the sets but not in both. Okay, but not in both. So we also have the subset that you can use to check if one set is a subset of the other one. Okay, if one set is a subset of the other one. So let me give an example. Let me say set 3 equal to, let me just say 1 comma 2 comma 3. All right, so I want to check now if set 3 is a subset of set 1. All right, I want to check if set 3 is a subset of set 1. I can just take this one out and I'll just print the response directly. So I can just come here and say, to check if it's a subset, I will just say um, set 3 less than or equal to set 1. Run this. You see that it is giving me true, and the reason is because set 3 is actually a subset of set 1. All right, so if I want to check for superset, it's almost the same thing. Just change this one, then this will be set 1 and this will be set 3. So it's a superset obviously, so it will be true. So that is how you can find the superset. Set operators provide powerful tools for manipulating and comparing sets in Python. Understanding these operators will help you efficiently work with sets and the operations in your code. Okay. Now let us check for membership. If you want to check for membership in a set, it is very simple. For example, this set 1, I can just come here and do something like 7 in set 1. If I run this, you see it is giving me false because 7 doesn't exist in set 1. If I bring 4 into this place and I run it, it is giving me true because actually 4 exists. Okay, so clear. So 4 exists in set 1. All right, so that is it. Other methods that the set has, I spoke about the add and the remove. So let us talk about the pop and the clear. Okay, the pop and clear. So the pop can be used to remove an arbitrary element. The pop can be used to remove an arbitrary element, while the clear can be used to clear the whole set. For example, I can just come here to say set 3 dot pop. So let me print set 3 after popping an element in set 3. Set 3. Run this. You see, I'm getting 2 and 3. It took 1 off. I'm always getting 2 and 3. Okay, it will just pop an arbitrary element. That is what it does. But if I say set 3 dot clear, you see it is giving me an empty set now. It's giving me an empty set now. So those are two other methods that we use in the set. Then we also have the frozen set. Okay, we also have the frozen set. A frozen set is an immutable version of a set. It's not as if the set is immutable anyway. So just the same way you have a I think a frozen list also. But in set, if you want to create a frozen set, just come here and do something like this. A frozen set. Let's say frozen equal to frozen set. Okay, it's only a frozen set you have. You don't have a frozen list, please. So one, two, three, four, and five. All right. So this is how you create a frozen set, basically. So print your frozen. Run this. You can see it is giving me a frozen set. If I should print nums, where is my nums? Print the two of them. You see that this is giving me the regular set, but this is giving me a frozen set. This is giving me a frozen set. So that is that about that. So we also have set comprehension. We also have set comprehension. Similar to list comprehension, you can create sets using set comprehension, and it is very, very simple. So a simple example for set comprehension is to do this. You can say a set of squares. So squares equal to, you bring your coily braces, x raised to the power of 2. Then you will now say for x in range of 1 comma 6. So this is basically you creating a set of squares. I can come here to print squares, and if I should run my code, you see what I'm having: 1491625. Clear my terminal so it can be better. You can see 1491625. Okay, so that is it basically. Lastly, we are going to be talking about nested sets. Okay, while sets themselves are not nested, you can have sets within other data structures. All right, so you can create a list of sets. In the case of the nested list, we have a list of lists, but you can't create a set of sets. So you can only create a list of sets. So you can have sets within other data structures. So how can we do this? You can say nested equal to, then you bring in your list, then you have a set 1 comma 2 comma 3. You have another set, maybe 7 comma 8 comma 9. You have another set, say, you have another set, maybe 2 5 3. All right, so just come here to print nested, and running my code. You see, I have 1 2 3 8 9 7, then 2 3 and 5, and that is it basically. That is it. With that, you create a list of sets. Okay, so Python sets are ideal for situations where you need an unordered collection of a unique element, especially where uniqueness is very, very important. Understanding this concept will enable you to efficiently use sets in your Python code. All right. So thank you very much for watching till the end. Don't forget to like the video and subscribe to the channel. If you have any comments or you need additional information, kindly drop a comment, and I'll try to respond as soon as I can. So thank you very much. I'll see you in the next tutorial where we talk about dictionaries. Bye for now.